What if the speed of light, c, is not a cosmic speed limit written by the universe, but a number we baked into our rulers and clocks? In the energy filament theory, local measurements of c can stay perfectly consistent while the deeper propagation properties of the medium slowly evolve, because we measure light using standards that may co-evolve with the same energy c. Here's the most telling fact that almost nobody says out loud. In modern definitions, the meter is literally tied to light. A meter is defined by how far light travels in vacuum in a specified fraction of a second, and the second is tied to a fixed count of atomic oscillations. Then we turn around and announce, look, c is constant. That is not fraud. It is a practical choice. But it is also a logical trap if you confuse practical consistency with a final verdict about reality. It's like defining one cup as whatever fills a standard cup, then proudly measuring that the cup always holds one cup. Of course it does. The stability is built into the definition. What your lab confirms, with extreme precision, is something narrower, in your local environment. The ratio between how far light goes and how many ticks your local clock makes is incredibly stable. That is a consistency test inside a chosen unit system. It is not by itself a guarantee that the underlying medium's true propagation behavior is identical across all cosmic history and all conditions. Now connect this to what we discussed last episode about rulers and clocks. Atomic clocks already show that internal rhythms depend on environment. Moves the same clock to a different height in Earth's gravitational field, and its tick rate shifts measurably. That means your second is not a mystical universal brick. It is a physical process in matter, and physical processes can respond to conditions. Your meter is not immune either. Real materials expand, contract, and stabilize their lattice spacing through underlying interactions. If the deeper environment changes, the stability conditions for matter can shift, even slightly. So the real question becomes sharp. When you say the speed of light is constant, do you mean light propagates in exactly the same way at every epoch and under every tension state of the universe? Or do you mean that, when you use locally defined rulers and locally defined clocks that are both anchored in local matter, the measured ratio stays constant? Those are different claims. One is about the universe's deep mechanism, the other is about the self-consistency of our local measurement triangle: light, meter, second. Here's the strange part. If your ruler and your clock are both made from structures that self-stabilize inside the same medium, then they can drift together. And if they drift together, you can keep measuring c as constant forever, even while the deeper properties of propagation slowly change underneath. You can picture it like surfing on an ocean while using a watch that is synced to the waves. If the wave speed changes and your watch changes with it, your ratio can stay the same. The world can evolve while your instrument keeps saying stable. That doesn't mean experiments are wrong. It means you have to be careful about what the experiments logically exclude. In this picture, the claim is not all light speed experiments are false. The claim is narrower and more surgical. Local experiments prove local coherence. They show that within a given time slice and a given environment, the relationship between light propagation, clock rhythm, and length standards is extraordinarily tight. That is an achievement, but it does not automatically rule out a long timescale possibility across cosmic history. As the energy sees tension relaxes and the background conditions shift, the true propagation characteristics, the internal rhythms of matter, and the stabilization of rulers can co-evolve in a coordinated way. And if they co-evolve, our measurements will mostly see invariance. Ratios that stay fixed, because our tools are built from the same fabric they are measuring. That is exactly why the energy filament theory takes a different turn. It does not argue with local precision. It asks what local precision can and cannot prove. Measuring c with units defined by c is not a direct interrogation of the universe's deepest layer. It is a test that our local physical language is self-consistent. The punchline is simple: c is constant might mean light is constant relative to our present-day meter and second. Not light's deepest propagation mechanism is eternally identical everywhere. Next episode, we chase the same issue into another sacred number. We'll talk about temperature and the feeling that absolute zero and Kelvin scales are the universe's own labels, and ask the same uncomfortable question: are we trusting the cosmos, or are we trusting our translation system? Tap follow, share it on New Physics, Clear Universe.